Today we're going to look at multiplying and dividing powers. Now let's look here. We are going to simplify this expression. Let's have a look. We'll go a to the fifth times a to the third. Now, what does this look like? Well, let's expand a to the fifth, and we shall expand a to the third, and I think that's it there. We have 5 factors in this term, and we have 3 factors in the second term. Now, in total, if you count them all up, there are 8 of them. So to simplify this, it's actually quite easy. You're simply going to express this as a to the 8th. Now, what did you actually do? Well, you added your exponents. 5 plus 3, and of course, that gave you your exponent of 8. Now, this can only happen when your base is the same. And we in previous lessons we looked at what's the base and what is the exponent and how you can tell which one is which. Okay, so let's go over and look at a definition. The product of two powers, and that's what this is called. Product of two powers. That's what this is referred to as. The product of two powers with the same base, in this case it's a, can be simplified by adding the exponents. We did that, and using the sum as an exponent of the common base. So just where we're going to use literal coefficients, letters, we could express this like so. A would be m plus n, where in this case the m was 5 and the n was 3. Okay, let's look at, just very quickly, let's look at another scenario here. N to the fourth times n to the third, and we would express it and show it like so. 4 plus 3, n to the seventh. Pretty straightforward. Now, let's look at dividing, and we're going to look at what's called the quotient of two powers. We might as well use the same, let's use the same example. Of course, different things are going to happen to it. Simplify. So now we have a to the fifth divided by a to the third. The first term, because I'm going to look at this definition over here, and that might be a little wordy, but the first term is called your dividend, and the second one is your divisor. The divisor is doing the dividing. Okay, so again, we can still expand 1, 2, 3, 4, 5, and we shall expand our divisor, our second term, and there's what this looks like. Now, we can cancel those a's, 3 a's on the top, 3 a's on the bottom, the numerator and the denominator, and we end up with the 2 that are left in the numerator and simplified a squared. Now, what did we do here? If you look, you don't have to do this, expand this every time, because we found a pattern, and the pattern is very similar to the pattern in the multiplying. In the multiplying example with the product of two powers, except this time we subtracted our two exponents to give us our result. Now, how is that going to look with the same scenario from our product of two powers? We have n to the fourth, let's write it like this, divided by n to the third. Now you can expand if you wish, n times n times n times n, and there's what that looks like. And there it is again. We can cancel, and we are left with n. Now, we're not going to do that every time, and you're not going to do that every time you're given a scenario or a situation with quotient of powers or product of powers, because they can be quite long. So here's your pattern in this example. You're simply subtracting your exponents, and you would end up with n to the first power, or simply n. Now, let's go over and we'll do the same thing with our quotient of powers that we did with our product of powers, and we'll have it look something like this. A to the m divided by a to the n, and we are subtracting our exponents, where in this case, the first case with the a base, a would be 5, I'm sorry, m would be 5, and n would be 3. Okay, so we'll do an exercise on this shortly, and look for that on my site, and we'll go through some examples, little mini activities for multiplying and dividing using powers.